All right, here's what I've got. Here's the problem I'm up against. I've got x squared plus 4x minus 1 is bigger than 5x plus 1. What I'm really asking myself is, when is this graph right here bigger than that graph right there? And so I can kind of think of this as two different equations. Now, this equation right here on the left-hand side, that's a parabola. We can identify that pretty quickly because of the x squared term. This equation on the right-hand side, that's a linear line. That's a straight line because of the 5x. That's the mx plus b form, right? So it actually crosses that positive 1, which deceivingly is not what my graph does, but you know, whatever. And then it has a slope of 5. And over here, this is a positive parabola that crosses that negative 1. So I'm asking, when is the parabola bigger than this thing over here? Now, what I'm really asking myself is, if I were to look at the graph, I'll be honest with you, the graph was really hard to graph, first of all. The second thing is, not only was it hard to graph, it's really hard for me to tell where those intersection points are, exactly where they are. Because after I tell the intersection points, I can tell you that, hey, the parabola is bigger on this side than the line, and the parabola is bigger on that side than this line, but I don't know what those x points are. Now, in order to do that, what I would do is I would say, well, when is this thing equal to that thing? So I have x squared plus 4x minus 1 is equal to 5x plus 1. I want to figure out what those 2 points are, and where this graph is equal to that graph. All right, let's take everything over to the left-hand side. I know that when we do these problems, usually we take all the x's over to one side and we'll take all the numbers over to the other side. Actually, I'll show you what. I'll tell you what. Let's do that. Let's take the 5x over to the left side. And so I have x squared. What is 4x minus 5x? That's negative x. I should also add 1 to both sides, because what I want to do is I want to take the number over to the right-hand side. So I have, this cancels that, and this is 1 plus 1, that's equal to 2. Now here's the problem, is I can't get x all by itself. So you realize, because this thing is a parabola that we're dealing with, so there is no x getting it all by itself ability. So here's what we're going to need to do. Why don't we just take everything over to the left-hand side? So we have x squared minus x minus 2 is equal to 0. When it's in this form right here, I actually kind of know how I might be able to solve it. What I would need to use is this is a quadratic equation, or this is a quadratic form, and I have it set equal to 0. I know the techniques to solve that. I can use the quadratic equation, I can complete the square. I might even be able to factor it. Let's see if that's possible. If I were to factor this, then I would have an x here and an x here. I feel like I want to have a negative 2 here and a positive 1 here. Will that give me the right answer? 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. I think I'm happy with this. This is it. This is the answer right here. So I know that my graph crosses at x equals negative 1 and x equals positive 2. So I can tell you when the parabola is bigger than the line. The parabola is bigger than the line on the interval between negative infinity and negative 1. And I can stop at negative 1 because I know that at that point they are equal to each other. And then in between negative 1 and positive 2, the line is bigger. So I don't want to include that side, but I can know that after positive 2, it looks to me like the parabola again wins. So I have 2 comma infinity. And that's the interval in which my answer is. Now, why did I end up having to solve a quadratic equation over here? And my answer is this. Because they cross at 2 different points. If I was indeed able to get this thing so that there was only an x on one side and there was just a number on the other side, then that would mean that I would have x equals some number. Whatever that number might be, x equals some number. But that's not the case, because that would only imply that x is one number. That means they only cross at one single point. And if I were to look at the graph, obviously I could say, no, that crosses at two different points. I just got to figure out what those 2 points are. When you have to solve for 2 separate points, you're dealing with a quadratic equation. I hope that makes sense to you.